Hi guys, this video is going to talk about basics required for solving trigonomericals. Alright, and to begin with, let's try and understand unit circle. Why do we call it as unit circle? We call it as unit circle because the radii of this circle is 1. Alright, and we would be rotating it this way. Now it is x-axis and this is y-axis. This is the origin, which is 0, 0, and this obviously, since it's a unit circle, so this would be 1 0 0 1 minus 1 0 0 minus 1. You know why it is like that. All right, that is what is coordinates. All right, now x-axis is cos, y-axis is sine. This you've got to keep in mind. Okay, now having that in mind, what happens if our indicator is here? If the indicator is here, it's lying on x-axis, so the angle formed is 0. And mind you, this would be moving anti-clockwise. Alright, so angle is 0. And we already told that this is corresponding to cos and this is corresponding to sine. So cos 0 is 1. Why? Cos 0 is 1 because of this reason. Alright, and sine 0 is 0. Why? For this reason. Okay, now we move in, we rotate it anti-clockwise direction and come over here. Now the angle becomes 90 degree. So this is for 90 cos, this is for 90 sine. This is the reason why cos 90 is 0 and sine 90 is 1. Another thing, keep in mind, what we found is when this was cos 0, the value was 1. But for cos 90, the value is 0. So cos theta is inversely proportional to theta. As the value of theta increases, the value of cos keeps on decreasing. Got it? Okay. Whereas in case of sine 0 was 0, whereas sine 90 is 1. So sine theta is directly proportional to theta. Anytime you get confused, you can keep this in mind. Alright, okay, fine. We move further. When we come over here, it becomes pi. Alright, so this is the value for cos pi minus 1, sin pi 0, and again when we come back over here, it becomes 270, right? It is. Now, see, it's always good to talk in terms of pi by 2. So when we come here, we call it as pi by 2. When we come here, we call it as pi, as I've already mentioned over here. When we come over here, we call it as 3 pi by 2. But instead of pi, I would wish that you call it as 2 pi by 2. Got it? And then, so for 3 pi by 2, cos 3 pi by 2 would be 0 and sin 3 pi by 2 would be minus 1. Similarly, when we come over here, it would be 2 pi. Alright, done. Now, does it stop there? No, it doesn't stop there. What happens is, it keeps on rotating, right? It keeps on rotating. So, this value 1, is it only for 2 pi? No. It would again rotate and come back here. And why? How many radians? It is why 2 pi. Alright, so 4 pi would also have this value. 4 pi for cos would also have this value. 4 pi for sine would also have this value. Similarly, it's true for every other place. Now here we are talking in terms of 2 pi. So keep on adding 2 pi to all these values. So we will find that the values would keep on repeating. Now this is what is called as coterminal formula. That is, to this 2 pi, I added another 2 pi. So it became 4 pi having the same value. I added another 2 pi having the same value. Now mind you, it's true also for all these places. Now so, just for example, if I say cos 0 is 1. Alright, so I add 2 pi to that using coterminal formula. So cos 2 pi also would be 1. I add another 2 pi. So cos 4 pi would also be 1. Similarly, we can talk in terms of all these values. Alright, so this is what is coterminal. So what is coterminal? The values keep on repeating if you keep on adding 2 pi to whatever you have chosen, right? So that's one thing, which is what is coterminal formula. Okay, all right, I hope you understood this part, right? You may be aware about these things, what I'm going to talk about, but if you are aware, it is fine. If not, please keep this in mind. It makes it very easy. Now, most of the times we get confused if I ask you what is sine 30, sine 45, sine 60, sine 90. I'll teach you a simple, very well known methodology to keep it in mind. Alright, now what you do is, first you know 0, 1, 2, 3, 4. You know those numbers, right? Okay, so 0, 1, 2, 3, 4. Alright, okay. And then I divide all these numbers by 4. Alright, so, and then what I do is, I root it. So this becomes what? 0, obviously. This is 4, root of 4. So this becomes 1 by 2. And this 2 cancels. So 2 is there. So it becomes 1 by root 2. And this would be root 3 by 2. And this would be 1. Alright. What you do is, you just put there 0, 30, 45, 60, 90 and put in here sine. Alright. Now see, how long did it take for me to do this? Hardly few seconds. So once you know this, you just jot it down in corner of your notebook wherever you have these trigo type of numericals. Alright. So what happens is, you don't have to scratch your gray matter to get the values. They are already there. So time is not wasted. So that is done. Now what about cos? Cos we know is complementary. So cos, just reverse that. Just put in, instead of 90, put in, start from here 0, 30, 45, then comes 60, then comes 90, put in cos. That's so simple. So you want to find tan, you want to find cot, you want to find cosec, you want to find sec, everything is there. Once you know cos, once you know sine and cos, things are done. Alright, so I hope this will be helpful. For those who are using it or those who have by-hearted those values, that's fine for them. But suppose you find problem in by-hearting those values, this becomes one of the simplest way to get away with values of these angles of sine, cos, tan, cot, cosec, sec. Okay.